Hello and welcome. This is my video on the booklet 2 of the revision notes of subject CT4, and this pertains to chapter number 3 and 4. Okay, so in this booklet you'll see that there are majorly past exam questions relating to chapter 3, which is almost all the questions, and there is just one question which relates to chapter 4. So chapter 4 does not really feature a lot in the CT 4 exam. It is mostly chapter 3, but chapter 4 is important for building your basics for chapter number 5. Okay, and that is why it is important. But major exam questions from this unit come from chapter number 3. Okay, so let's start looking at a few questions, and this is the first question that I'm taking is subject CT4 April 2006, question number A3. Okay, so let's look at this. It says that a motor insurer has a no claim discount system and it uses the following levels of discount. Okay, so there are 4 levels of discount given here: 0%, 25%, 40% and 50%. Okay, and then you have got this conditioning here that following a claim free year, a policyholder moves up one discount level or remains at 50% discount. Okay, so if there is no claim, the policyholder moves up, okay, but to a maximum of 50% discount level. If the policyholder makes one or more claims in a year, they move down one level or remain at 0% discount. Okay, so basically what they're telling us is that there are 4 discount slabs, and if you make a claim, you move down. If you do not make a claim, you move up. The insurer estimates that the probability of making at least one claim in a year is 0.1 if the policyholder made no claims in the previous year. Okay, so if there was no claim in the previous year, the probability of making a claim is 0.1, and if there was a claim in the previous year, okay, then the probability of making a claim is 0.25. So here we can clearly see that the future state of the policyholder, the probability to which state the policyholder gets, depends upon the past state. Okay, it depends on whether you made a claim last year or not. Okay, so clearly you can see that this process is not a Markov chain, and we'll need to modify the state space in order to make it a Markov chain. Okay, so it's not Markov because the probability of moving up or down, that is making claim or no claim, it depends on whether you made a claim last year or not. Okay, so it just does not depend on the current level of discount you are at, but also depends on the last year's level of discount or last year whether you made a claim or not. Okay, so now they are asking us explain why the system with the state space 0%, 25%, 40%, 50% does not form a Markov chain. So clearly this does not form a Markov chain because the state in which the policyholder will be in the next year depends also on the past year state, that is whether you made a claim last year or not. Okay, so the future cannot be completely modeled by the present state, and the past provides additional information in order to model the future. Okay, so in order to show it properly to you, I can take an example of this. So just to prove this, you can write a contradictory example, that probability that x t plus 1, okay, that is the future state. If t is the present time, t plus 1 would be the future state. This is equal to, let's call it 25%. The probability of this being 25%, given that xt was equal to 40%, that is you were on a higher level of discount previous year, that is you made a claim this year, and xt minus 1 was equal to 50%, so you had also made a claim last year. This probability is basically equal to, if you see, this probability is equal to if you made a claim last, then your probability of making a claim in the next year as well would be 0.25 as they said in the question. Okay, but the probability that xt plus 1 is equal to 25%, given that xt is equal to 40%, that is the probability of falling down, that is making a claim in this year, given that xt minus 1 is equal to, let's say, 25%, that is you rised up one level last year, that is you did not make a claim last year, that is why you rised up. So you got from 25 to 40 in the last year, from t minus 1 to t. That means you did not make a claim last year. So this implies the probability of making a claim this year, that is getting back to 25%, this probability would now be equal to 0.1 because you did not make a claim last year. Okay, so since these two probabilities they are not equal, these are not equal, okay, let's call this A, let's call this B. Okay, since A is not equal to B, therefore this process is not Markov, because between A and B the only difference is that xt minus 1 is different, but this should not affect the probability. Clearly Markov property states that probability that this state can be modeled completely by the information of this state, and this state should not affect it, but this state is affecting it clearly, so this process is not Markov. So now in the next part they are asking us, show how a Markov chain can be constructed by introduction of additional states. So now we'll try to see how we can make this process Markov. Okay, now let's just see how can we make this process Markov. Okay, so the problem here is that the last year state, or the condition whether the person made a claim last year or not, also affects the probability of the future state. Okay, that is the probability of making a claim next year or not as well. Okay, so that is affected here, and that is why the process is not Markov. So how would we make it Markov? We'll need to modify the state space. Okay, so we have got the existing state space, which is 0%, 25%, 40% and 50%, and we have been told that the probability of claim, given that there was no claim last year, is 0.10. Okay, and the probability of claim, given that there was a claim last year, okay, this probability is given as 0.25, and this makes a lot of sense, right? It makes a lot of sense because the policyholder who had made a claim last year will expect it to make a claim this year with a higher probability, right? And the corresponding probabilities of no claim would be 0.9 and 0.75. That is the probability of not making a claim this year, given that there was no claim last year, will be equal to 0.9, and the probability of not making a claim this year, given that there was a claim last year, would be 0.75. Okay, so these are the probabilities that you have, and clearly the next state, the probability of the next state depends on the past state as well, right? And not only on the present state that you are occupying. So for example, if a person, okay, he is at 40% level of discount, he can move to 50% level of discount with a probability of if he does not make claim, right? So with a probability of 0.9 or with a probability of 0.75, depending on whether or not he made a claim last year. Okay, that is the consideration here, right? Okay, now how do we model this? Okay, if he had made a claim last year, then he would have moved from if he is in 40 right now, and he had made a claim last year, he would have moved from 50 to 40, right? This would have been his transition last year, right? And if he did not make a claim last year, then he would have moved up from 25 to 40 last year, right? That is what would have happened logically, right? Because if he didn't make a claim, he would have moved from 25, okay, and if he had made a claim, he would have moved down from 50, and that is why he is in 40 right now. Okay, so if he was in 25 last year, that is he did not make a claim last year, then the probability of him not making a claim this year and moving to 50 would be 0.9. And if he was in 50 last year and he had moved to 40 last year, that is he made a claim last year, then his probability of moving from 40 to 50 would be 0.75. Okay, so I need to split 40 into two parts based on whether he moved from 25 to 40 or 50 to 40, right? So let's just do that. Let's split 40 into two halves. Okay, so how do I do that? I'll make two states, 40 plus and 40% minus, right? I can make two states as such, and 40% plus means let's define these states. Okay, so I'm splitting 40% state into two parts. There is 40% plus, that is the policyholder is at 40% discount given that he did not make a claim last year. That is, he was at 25% last year. A claim last year, right? And 40% minus can be written as the state where the policyholder is at 40% discount given that he had made a claim last year. So he had made a claim last year, right? So that's how you can define it actually. Okay, so I've splitted 40% into two parts based on whether he made a claim last year or not, and there can be a similar split for 25% as well. Okay, so you can have 25% plus and 25% minus. Okay, based on whether the policyholder is at 25% given that he didn't make a claim last year, and this would be 25% given that he made a claim last year. So that can be your split for these two states. So let's just try to see it now. What does this mean? So I'll have two states now, 25% plus and 25% minus here. Okay, so if you are at 25% plus this year, this means that you are at 25% level of discount and you did not make a claim last year. Okay, so that is you moved from 0% to 25% plus. Okay, and if you had made a claim last year, then you had moved from 40% to 40% whatever the state you were in to the state 25% minus. Okay, so these two states need to be split. Now let's see if we need to split 0% and 50% as well. Now if you are at 50% level of discount, that is the highest slab of discount. So if you had made a claim last year, you would have moved down anyway from it. So the state that you are in, 50%, if you are at 50% level of discount, it in itself means that you did not make a claim last year, because if you had made a claim last year, you would not have been at 50%, the highest rate, right? You would have automatically moved down, right? So basically if you are at 50% level, this in itself means that you did not make a claim last year. So basically this state, it does not need to be adjusted because it in itself contains the past information within itself. Okay, and you do not the past state does not provide any additional information. So if you are at 50% level of discount, that in itself means that you did not make claim last year. Similarly for 0% level of discount, if you are at 0% level of discount, it is sure that you had made a claim last year, because if you did not, you would have moved up. Okay, and one exceptional case you can think of is 0% level of discount if you are a new policy holder. So if a new policy holder begins at 0% level of discount, that does not mean that he made a claim last year or he did not, because he did not have a last year. So those cases can be ignored here because it is written in the question that you can ignore the new policyholders. Yeah, this is written, new policyholders should be ignored. So basically 50% and 0% in themselves indicate that if you are at 50%, it is sure that you did not make a claim last year, okay? And if you are at 0%, you surely made a claim last year, right? So these are the only two states which need to be split and other states do not. Now let's define the probabilities in this diagram. Okay, so you are at 0% level of discount. Okay, that means you had made a claim last year for sure. So the probability of moving up, now you will move up to 25%, right? Because when you move ahead to a plus state, because this indicates that you are at 25% level of discount and you did not make a claim last year. So you have to move from 0% to 25% plus. Okay, and 25% minus indicates that you are at 25% level of discount, but you had made a claim last year. So whenever you move backward, you move to a minus state. Okay, that means that you had you move from 40% plus or minus to 25% minus, because that would indicate that you are at 25% level of discount and you had made a claim last year. Okay, so that's how it functions. Okay, so from 0% you can only go up to 25% plus, which would indicate that you are at 25% discount now and you did not make a claim last year. So this probability would be 0.75, because if you are at 0% level of discount, it in itself implies that you had made a claim last year. So this probability would apply, right? So this is 0.75 of making a claim. Okay, the probability of this would be 0.25. The probability of making a claim given that you had made a claim last year is 0.25. So this would be 0.25, and the probability of staying here would be 0.75. That is the probability that if you had made a claim, what is the probability of making a claim again. So if you make a claim again, you'll stay here itself, okay, because you cannot go any lower than this. Okay, now if you are at 25% plus state, that means you had not made a claim last year. Okay, so the probability of moving ahead would be not making a claim, that would be 40% plus. Okay, so this can be indicated as I've made an arrow already, so this would be indicated as 0.9. That is the probability that you did not make a claim last year and you do not make a claim this year as well, so you move ahead. Okay, and the probability of going back to 0 again, because this indicates that you did not make a claim last year, the probability of going down would be 0.1, right, because you did not make a claim last year. Okay, so not making a claim becomes 0.1. Okay, so 25% plus can be modeled like that. Now if you are in 25% minus, that means you had made a claim last year. Okay, and if you had made a claim last year, the probability, now you'll move up to plus 40% plus, because that indicates that you did not make a claim last year. So if you are moving up, and if you are not making a claim, then you will move up to 40% plus. Okay, you always, whenever you move ahead to a plus state, and whenever you move back to a minus state, right? That's how you have to remember it. Okay, so from 25% plus, 25% minus, you will move to 40% plus, and the probability would be, because minus indicates that you had a claim, so these two probabilities apply. Okay, so if you had made a claim last year, the probability of moving ahead is 0.75, and the probability of moving down you will move to 0% would be 0.25, right? That is probability of making a claim. Again, if you are in 40% plus, this indicates that you did not make a claim last year, so your probability of moving ahead would be 0.9, and moving back, you will go back to 25% minus, right, because this indicates that you made a claim. Okay, and this probability would be 0.1, because last year you did not make a claim, because you are in a plus state. Okay, right. Now if you are in 40% minus, this indicates that you had made a claim last year. Okay, so you move ahead with a probability of 0.75, right, and you move back to 25% minus, of course, because whenever you move back to a minus state, and this probability would be 0.25, because you had made a claim last year, right? And now if I talk about the 50% state, if you do not make a claim, okay. And this in itself means if you are at 50% level of discount, in itself it means that you did not make a claim last year. So these two probabilities will apply, right? Okay, so basically staying here is 0.9, and going back you'll always go back to a minus state, okay, because that would indicate that you have made a claim and you move to a minus state, and that would be 0.1 in this case because you are at the highest state, and this indicates that you did not make a claim last year. So that is why you are in the highest state, and that is why you'll move down with 0.1 and you'll move up with 0.9, right? So that's what your transition diagram will look like, right? You can also make a transition matrix. They have asked you to write down the transition matrix or the transition diagram. So whatever you want to do, you can do. I've made the transition diagram. With the help of this, you can make the transition matrix, okay? So this is what it will look like. And then they're asking you comment on the appropriateness of the current no claims discount system, okay? So the comment that you can make is that it seems very appropriate in the sense because whenever a policy holder had made a claim last year, his probability of making a claim this year will also increase, right? So that's why that's the basic idea behind the model, okay? So if you consistently do not make claims, then you are likely to perform better, and your probability of not making a claim, that is that essentially implies that you are a good driver, or you make less claims, okay? So that way you can think about it. And a few comments you can make is like that it does not consider any information before the last year, okay? So basically you are ignoring all the information which is before the last year, and there can be other things like that, okay? So you can say that it can also so happen that these probabilities are time dependent, okay? Because in rainy seasons your probability of claim would be higher, and in summers your probability of claim would be lower. The accidents would depend on the seasons. So that way for that you need a time inhomogeneous model which also depends on time and not only duration. Here it is a time homogeneous model which depends only on the duration. That is, the one step transition probabilities are constant here, right? So that can be one consideration. So throughout the year we have considered the probabilities to be the same, but they can vary with seasons. That can be the case. And yeah, those are a few comments that you can make here, okay? So otherwise the model is appropriate and it makes sense, okay? So that's how you'll design this model. And once you have designed this model, even if they ask you to calculate the long-term distribution, that is the stationary distribution of this and everything, you can do that, okay? But in this question they have not asked any such questions, okay? So let's move on to the next question now. Okay, so the next question I'm looking at is subject CT4, question number A4. Okay, so the credit worthiness of a debt issued by companies is assessed at the end of each year by a credit rating agency. So companies are issuing debt, and credit rating agencies are rating them, their debentures probably. Okay, the ratings are A, the most credit worthy, okay? So there are multiple ratings. The first rating is A, which is most credit worthy, B, which is lower to A of course, and D, which is debt defaulted, okay? So there are three ratings, A, B and D, okay? So this is like the best one, okay, and this is the worst one, okay? So that's how you can look at it, okay? And this is debt defaulted, that is they have already defaulted the payment of their debt, okay? So once they have defaulted, they cannot come out of this category D, okay, right? So this is defaulted, right? So they are saying historic evidence supports the view that the credit rating of a debt can be modeled as a Markov chain with 1 year transition matrix as this. So they've given us a Markov chain with a 1 year transition probability is given as follows, and they're asking us to determine the probability that a company rated A will never be rated B in the future, okay? So that's what they're asking us the probability for. So what is the probability? That if a company is currently rated A, it will never be rated B in the future. It can be directly rated C, but it can never be rated B. Okay, that's the probability I'm trying to assess. Okay, so how do I do that? Okay, let's see. So if a company is currently rated A, okay, three things can happen to it. It can either go from A to A itself again with a probability which is 0.92, which is given right there. It can go to B, which I do not want to happen, which is 0.05, and it's C with the probability 0.03, right? So this is what they've given us, and they've asked us the probability that a company which is rated A right now is never rated B. Okay, and in the next year as well, if it is rated A, again there can be three possibilities, which can be A, B and C with the same probabilities, right? So you can have 0.92, 0.05 and 0.03. But whatever company is rated C, if you see the transition matrix properly, it stays in C. Oh, sorry, this is not C, this is D. So yeah, a company which is rated as D once cannot go back to A or B again, because this probability is 1. So whatever gets to D stays in D, right? It does not get back to A or B because it has already defaulted, right? So I need to calculate the probability that a company which is currently rated A will never be rated B. So this becomes like, if I want this probability, the probability of never being rated B, if it's rated A right now, will be in the first year it does not have to go to B. Okay, so it can either stay in A or it can go to D. Okay, so it either goes to D, that is 0.03, or it stays in A, which is 0.92, right? Now in the next year, if it stays in D, that is fine. If it comes to A again, then again the same thing can happen. Again it can go to D or it can stay in A, right? But it should not go to B. So I'm just avoiding those probabilities, right? So again it can be either in A, this is D, this is A, this is D, again A, right? And again when it is in A, it can again go to D or it should stay in A, and so on and so forth. This will keep on going. So this is the probability that it is never rated B in the future. It stays in either stays in A or is directly rated B. So this becomes 0.03 plus 0.92 into 0.03 if I multiply it, plus 0.92 into 0.03. This is 0.92 square, right? It would be multiplied 2 times now, this one, and then into 0.03 plus 0.92 cube into 0.03. So if you see this becomes a geometric progression, and the sum can be calculated as A upon 1 minus R. So that is 0.03 divided by the 1 minus the common ratio. So the common ratio is 0.92. So 1 minus 0.92. So this becomes 0.03 divided by 0.08. So that becomes 3 by 8, right? So that is 3 by 8. Okay, so that's how you calculate this probability. Now let's look at the next part. Okay, now they are asking us calculate the second order transition probabilities of the Markov chain. Okay, second order, if this is X, second order transition probabilities would be given by the transition matrix X square. So that is pretty easy to calculate. You can calculate it, and I'll just directly write the answer. Okay, so X square would be X into X, forward multiplying X by X. That would give me the following matrix, which would be equal to, let's just see, yeah, it would be equal to, right? So this is what your matrix will look like. Okay, This is my transition matrix. Next part of the question says that hence calculate the expected number of defaults within the next 2 years from a group of 100 companies, all initially rated A. Okay, so you have 100 companies which were all initially rated A, and you want to calculate what would be the expected number of defaults, that is what will be the number of companies D which get into D, which are rated D within next 2 years. Okay, so let's try to see that. So your initial distribution is given here. Okay, your initial distribution is given here as 100, 0, 0, all are rated A. So if you have A, B and D, okay, your initial distribution is this, and you want to find out what would be the proportion of company which would have defaulted after 2 years. So I can just directly multiply it with x square in order to find that probability, because I'll just multiply it with x twice, right? So I can multiply it with x square, so that would become 100, 0, 0, and this will be multiplied with this entire set of this entire matrix x square, which is right here, and you just need the third column of it. You just need to multiply it with x square, so I'm just writing x square here, and you would just need the proportion of companies which have dead defaulted. So I can just avoid writing the first two values, and the third one would be equal to, if I see, next part of the question says that hence calculate the expected number of defaults within the next 2 years from a group of 100 companies, all initially rated A. Okay, so you have 100 companies which were all initially rated A, and you want to calculate what would be the expected number of defaults, that is what will be the number of companies D which get into D, which are rated D within next 2 years. Okay, so let's try to see that. So your initial distribution is given here. Okay, your initial distribution is given here as 100, 0, 0, all are rated A. So if you have A, B and D, okay, your initial distribution is this, and you want to find out what would be the proportion of company which would have defaulted after 2 years. So I can just directly multiply it with x square in order to find that probability, because I'll just multiply it with x twice, right? So I can multiply it with x square, so that would become 100, 0, 0, and this will be multiplied with this entire set of this entire matrix x square, which is right here, and you just need the third column of it. You just need to multiply it with x square, so I'm just writing x square here, and you would just need the proportion of companies which have dead defaulted. So I can just avoid writing the first two values, and the third one would be equal to 6.26. okay, so this is the number of companies out of 100 which were initially rated A would have defaulted at the end of 2 years. Let's look at the next part. Next one says that the manager of the portfolio investing in the companies follows a downgrade trigger strategy. Okay, so he has decided to follow a downgrade trigger strategy. Under this strategy, any debt in the company whose rating has fallen to B at the end of a year is sold and replaced with debt in an A rated company. Okay, so basically what he'll do is, at the end of the year, first year, he'll just sell off all the companies which are rated B, and he'll replace them with the A rated companies. Okay, so this is a downgrade trigger. So if they downgrade, you just replace them. That is what they're doing. Okay, so calculate the expected number of defaults for this investment manager over the next 2 years, given the portfolio initially consisted of 100 companies. Okay, now they have tweaked the question a little bit. They are telling us that initially there were 100 companies, but now they are following a downgrade trigger strategy. That is, at the end of the first year, he'll replace all the companies which are rated B with the companies which are rated A, and then he'll again see what happens at the end of 2 years and how many companies have defaulted. Okay, so again we are starting off with 100 companies, okay, and in the first year I apply the same matrix to it, okay, which was x, which was given as 0 0.92, 0 0.05 and 0 0.03 and 0 0.05, 0 0.85, 0 0.1 and 001. Okay, this is the matrix that I apply to it, and at the end of the first year my distribution becomes, this was my x0, x0 was equal to 100, 0, 0, right? X1 would be equal to this, which would come out to be, if you check it, 92, 5 and 3, okay, because I just multiplied directly. Now in the second year what I'll do is I'll replace all the companies which are rated B, that is these 5 companies, with all the companies which are rated A. So your revised distribution becomes 97, 0, 0, right? This is 97, 0 and 3. Okay, so all these 5 companies have been replaced with the with A rated companies. So A rated companies increase by 5 and your B rated companies become 0. Okay, now I can calculate x2, which would come out to be 9703, and I'll multiply it with 0.92, 0.05, 0.03, 0.05, 0.85, 0.1, 001. Right, now if you multiply them, what does it become? Let's see. So if you multiply them together, it would come out to be finally 89.24, 4.85 and 5.91. So ultimately your defaulted number of companies come out to be 5.91. okay, so earlier it was 6.26 without the downgrade trigger, but with the downgrade trigger it comes out to be 5.91. okay, let's see the next part. So now they are asking us comment on the suggestion that the downgrade trigger strategy will improve the return on the portfolio. So you need to make a comment here. So now we can observe that the number of companies that have defaulted have actually reduced with the downgrade trigger. Earlier they were 6.26 and now they're just 5.91. okay, so 6.26 is greater than 5.91. Thus the number of defaults on this portfolio have definitely reduced, but we also need to consider all the transaction costs which are involved for selling the companies which were rated B and buying the companies which are rated A, right? We need to take them into consideration, right? And that is why we can see that this is not necessarily a good return decision, but it definitely reduces the number of defaults. So that is the comment that you can make. Okay, so thank you, that's all for this video. I'll discuss a few more questions in the next one.